In this video, I'm going to go over lesson 15, quadratic equations with irrational solutions. So basically, we're going to start looking at solutions that involve like square roots. So to start with our warm-up, it says here are some squares whose vertices are on a grid. Find the area and the side length of each square. So there's a couple different ways you could approach this with each square. So you can go ahead and pause this if you want to and go ahead and try to figure out the area and side length of each square. Hopefully you can at least do square A and then maybe see if you can figure out square B and C, and then you can resume the video and I'll go through it with you and tell you what the answers should be. Alright, so for square A, there's a couple ways you could go through this. You could start by finding the side length. 1, 2, 3. Side length is 3. And then if the side length is 3, then you just square that to find your area. So 3 times 3 would be 9. You could have also just counted all the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 squares, so the area is 9 square units. Okay, for square B, I think it's actually going to be easier to start with the area for this one. So let's start by trying to find the area by counting the squares. You can kind of see that there's sort of like this is a half of a square here. And then there's another half of a square here. And then there's another half of a square here. And then there's another half of a square. So there's 4 halves of a square. So basically these, like for example, these two could add together to make 1 square, and these two could add together to make another square. So there's in total 2 whole squares. So then if the area is 2 square units, we can kind of go backwards and try to figure out what the side length is. So the side length is not going to be 1. You might think, well, okay, it goes diagonally from one corner of the square to the other corner of the same square, so it's 1. But it's not. It's not 1. It's not going to work out that way. If it was going this way, here to here, that would be 1, but diagonally it doesn't work that way. And you know that doesn't work because if the side length was 1, 1 squared is 1, so then the side length is 1, the area should be 1, not 2. Okay, so basically, to find the side length, well, we know that our area was our side length squared. So let's say our area, or our side length, let's say our side length is x. Then we can say x squared, when you take your side length times your side length, which is your area, that's 2. Then you can square root both sides to actually get just x, which is just your regular side length, which is the square root of 2. You can't simplify the square root of 2, so we're just going to leave it as the square root of 2. That's an irrational number. Basically, that means that it's going to have decimals that go on forever. Okay. And then you can see if you square the square root of 2, you're going to get 2. So that makes sense. Okay. C. I think the way we can figure this out is by trying to add up all the squares and seeing what we get. So this is going to require a little bit of like being able to visually see like what portions are going to make a whole square. So you can start by saying, okay, there's 4 squares right here. That's pretty straightforward. There's 4 whole squares there. And then we kind of got to deal with the rest of these partial squares and see how they add up. So I'm looking at this and it looks like this tiny little piece here with this big piece here is going to make 1. And then we have more of those. We have another tiny piece here with this big piece. I think that's going to make 1 whole square. And then this tiny piece here with this big piece here will make 1 whole square. And then this tiny piece here with this big piece here will make a whole square. So now I have, with each of my colors is 1 square now. So I have 4 in the middle, and then I have 1, 2, 3, 4 more, because each color is 1 whole square. And then I'm also seeing that it looks like if you combine like these 2 white ones and these 2 white ones, they'll combine into a whole square together. Let's see if I can get 1 more color. I'll use pencil for these here. So like this one and this one can combine into 1. And then let's see if I can get 1 more color here. This one here. And this one here. Okay. So I have 4 in the middle. And then the orange is 1. Green is another one. Light blue is another one. And my purple is another one. So that gives me 8. And then I got to add in these 2 together, make 1. So that's 9. These 2 make 1. So that's 10. Okay. So after all that, I figure out that my area is 10. At least that's what it seems like by counting the squares. So then if my area is 10, then I know that my side length I have to be able to take my side length squared and get 10. Same thing like we're doing here. So again, we can say our side length is x. So x squared gives me 10. So then if I square root both sides, then my x, which is my side length, is just the square root of 10. And we can't simplify that. So we're just going to leave it as the square root of 10. And these are what we call irrational numbers, because the decimals go on forever without repeating any pattern or anything like that. So it's a number that we can't really, it's basically a number that we can't express as a fraction. Almost all other numbers can be expressed in some way as a fraction, but these numbers can't. Okay, so let's look at 15.2, solutions written as square roots. Okay, so it says solve each equation, use the plus minus notation when appropriate. And I'll explain the plus minus notation when we get to that point. So, what I'm going to do here is, since I don't have like what we call a linear term, like a term with just an x, not an x squared, I just have an x squared and I have constants. When I have that situation, I can just get my constants on one side. So add 13 to both sides and I end up with x squared equals, let's see, negative 12 plus 13 is just going to be 1. Then I'm going to square root both sides. And I'm going to get x equals, you might be thinking 1. That's not wrong. But it's actually positive or negative 1. So this is basically saying that x can be positive 1 or x can be negative 1. So it's the same as saying x equals 1 or x equals negative 1. But you can just do plus minus 1 like this as sort of a shorthand way to do that. So remember, if we have 1 squared gives us 1, then negative 1 squared will also give us 1. And the reason we didn't do that up here, like you might be thinking, okay, why didn't we say plus minus square root of 2 or plus minus 3? And that's because we were dealing with a side length, and a side length can't be negative. But if we were just dealing with arbitrary numbers and not a real life, like a side length, for example, then you would want to include that negative as a possibility too. Okay. Now we have x minus 6 squared equals 0. Okay. And if you think back to completing the square, it's nice when we have something squared equals a constant, because we can just square root both sides. And then we have x minus 6 equals 0. Square root of 0 is still 0. And then just add 6 to both sides. So x equals 6. Let's see. X squared plus 9 equals 0. Remember how I said, like, up here, we could get our constants on one side and just x squared on the other side. So let's subtract 9 from both sides. So x squared equals negative 9. So if we square root both sides, x equals, we can say plus or minus the square root of negative 9. Now, I'm going to tell you right now, this is not a real number. In the next unit, we're going to look at imaginary numbers, and that's where we'll look at this kind of solution a little bit more. But this is not a real number. So at this point, we would say no real solutions, because we don't know how to do imaginary numbers yet. Okay. Next one. So now we have x squared equals 18. So remember, it's nice if you have just something squared equals a constant, because you can just square root both sides to solve for x. So then x is going to equal the square root of 18, and we want to say plus or minus the square root of 18. I'm not going to simplify the square root of 18 because we don't really know how to do that at this point, but you can just say plus or minus the square root of 18. So we're remembering that you could have negative, so whatever the square root of 18 is, like if you plug it into your calculator, it'll give you like a decimal. But you got to remember that you can also have negative of that. Just like if we had x squared equals 9, square root of 9 would be 3 or negative 3. So we want to remember this plus or minus. Okay. Number 5, x squared plus 1 equals 18. Again, if we just get all of our constants on one side, we can have x squared equals 17. And then we can just square root both sides to get our answer. And again, we can't simplify the square root of 17. So I'm just going to say x equals plus or minus the square root of 17. Last one. Again, we have something squared equals 18. So again, we can still just square root both sides. So then x plus 1 equals positive or negative square root of 18. Then you can subtract 1 from both sides. And this is where it gets a little confusing. So since we can't simplify the square root of 18, like we can't get rid of that square root, we're just going to say x equals negative 1 plus or minus the square root of 18. So this is two solutions, remember. Don't forget that even though it looks like it's one solution, it's either negative 1 plus the square root of 18 or negative 1 minus the square root of 18. Just like how this is two solutions, positive square root of 17 or negative square root of 17. Okay. Finding irrational solutions by completing the square. Okay, so let's look at this problem. It says, here's an example of an equation being solved by graphing and by completing the square. So they graphed, they're trying to solve by graphing as well as solve by completing the square. So remember, we said that we could graph. Basically, they just graphed this side. They graphed like y equals x squared plus 6x plus 7, and then looked for the x-intercepts. And these are the x-intercepts that they got. And then, so these are hypothetically the solutions. And then when they solved by completing the square, so they added 2 to both sides to complete the square. So x plus 3 squared equals 2, square root both sides. You get x plus 3 equals plus or minus the square root of 2. Then you subtract 3 from both sides and get x equals negative 3 plus or minus the square root of 2. So we can verify that the square root of 2 is approximately 1.414. So if you do negative 3, and remember, this is approximate, it's not exact, but this is basically saying that x equals negative 3 plus 1.414, or x equals negative 3 minus 1.414. So if you actually calculate that, that'll give you negative 1.586 and negative 4.414, approximately. So we completed the square here, and then we square rooted both sides. We ended up with an irrational number on this side, but we can still just subtract 3 from both sides, and then we end up with negative 3 plus or minus the square root of 2. Okay, so it says for each equation, find the exact solutions by completing the square and the approximate solutions by graphing. Okay, so I'm just going to go through how to find the exact solutions by completing the square. You can look at graphing as well if you want to, and you should be able to see that when you graph it, your x-intercepts. So for example, on this one, if you graph it, your x-intercepts should be the same value as the solutions that you get when you solve this. Okay, so let's complete the square here. So remember, we want to look at what's 4 divided by 2. This number divided by 2. That's 2. 2 squared is 4. So that means that we want to have a plus 4 on this side. So what I'm going to do is I'm just going to add 3 to both sides so that I end up with a plus 4 over here. So I'm going to do x squared plus 4x plus 4 equals 3. And I know that this is the same as x plus 2 squared. I figured that out when I figured out that half of 4 was 2. So when I completed the square, I made it x plus 2 squared. And that equals 3. You can square root both sides and get x plus 2 equals 3, or, square root of 3, or x plus 2 equals negative square root of 3. So then you can subtract 2 from both sides. So I'm going to say x equals negative 2 plus the square root of 3, or x equals negative 2 minus the square root of 3. And you could combine that into one statement saying x equals negative 2 plus or minus the square root of 3. All right, number 2. we want to complete the square again. Half of negative 10 is negative 5. Negative 5 squared is going to be 25. So if I want to get 25 here, I can just add 7. I can do x squared minus 10x plus 25 equals 7. And now I just completed the square, so I made that x minus 5 squared equals 7. Square root both sides. I get x minus 5 equals plus or minus the square root of 7. Add 5 to both sides. So I get x equals 5 plus or minus the square root of 7. Alright, I'm going to stop there. There's a couple more equations that you can practice on if you want to. But I'm going to stop there. Obviously, let me know if you have any questions. But yeah, that's lesson 15, and that'll be the last lesson for this unit.